In this video, we'll discuss shading elements that can be used in materials. It builds on concepts introduced earlier in the series, so I recommend at least watching the concept section and the first materials section before this one. We'll start by setting up our renderer and SDFs. I'm going to run through this part quickly since this isn't the main focus of the video. Open the palette with the Alt-R shortcut and create a RayMarch Render 3D. And then create a null top so you can see the output. I'm going to set the resolution on the renderer to fit in the side panel, but you do not need to do that. Select the renderer and use the Alt-Shift-R shortcut to open RayTK's Editor Tools menu and choose Add Look At Camera. And then on the camera, we're going to set the FOV angle to 70 and the position to 3, 3, 5. And then we're going to set the look at position to 0, 0.20. Select the renderer again and open the Editor Tools menu with Alt-Shift-R and choose Add Point Light. And then on the light, we're going to set the position to 6, 6, 4. Select the renderer again, and in its parameters, switch on Enable Shadow. Open the palette again with Alt-R and create a box frame SDF. And we're going to connect that to the first input on the renderer. Open the palette again and create a Mobius ring SDF. And then on that, we're going to set the axis to Z, the radius to 0.9, the thickness is going to stay at 0.2, and the rounding we're going to increase to 0.1, and then for twist, we're going to set that to 1. Open the palette again and create a sphere SDF. And set the radius to 1.2. And then finally, we're going to create a plane SDF and set the offset to -1. Then we're going to select all 4 of these SDFs and open the Editor Tools with Alt-Shift-R. And under Arrange SDFs, we're going to choose Simple Union. And then we're going to connect this arrange to the first input on the renderer. In the Arrange's parameters, switch on Enable Translate. And we're going to set Translate 2, this is for the Mobius ring, to 1, 1, 0. And then for Translate 3, we're going to set that to -1.5, 0, and 0.5. And then we'll leave the rest as they are. And then on the Arrange, we're going to switch on this Optimize setting. This setting sort of locks in all the parameters and optimizes the code. The result is that any change to any of the parameters will cause a shader recompile and TouchDesigner will stall, but as long as none of them are changing, it's going to be a lot more efficient. Now that we've set up the renderer and SDFs, we can start trying out materials. Create a modularMat. And we're going to insert that between the Arrange and the renderer. Recall from the previous materials section that modularMat lets you choose and combine different types of shading to use as a material for surfaces. Right now it's dark because we haven't set up any shading elements yet. Open the palette and create a diffuseContrib. And we're going to connect that to the second input on the modular material. Then we're going to increase the albedo to 1. Diffuse shading uses lighting that's more spread out versus specular, which is more about shine and highlights. Since we already covered diffuse shading in the first materials section, we'll just use it as a comparison in this video. The first shading technique we'll discuss is goochShading, which I may be mispronouncing, might be gooch. So open the palette again with Alt-R and create a goochShadingContrib. And we're going to connect that in place of the diffuseContrib. This type of shading is a non-photorealistic technique that uses a range of two colors that it calls cool and warm. It uses the warm color for parts of the surface that are facing towards the light source, and the cool color for parts that are facing away from it. Note that in some versions of the toolkit, the warm and cool colors may be swapped due to a bug, so you can see here the cool color is what's showing up facing the light, and the warm color is the back. That will be fixed in future versions, but something to keep an eye out for. Try changing the two colors, and you can see how it will change different parts of the rendering. So what should be the cool color affects kind of those parts that are facing somewhat away from the light versus the other parts that are facing towards it. Try moving the light source and see how that changes which colors are used where. This type of shading is often used in technical illustrations when you're trying to give a sense of the three-dimensionality of a surface without trying to make it look photorealistic. Next up is iridescence. Create an iridescenceContrib, and we're going to connect that in place of the previous one. This shading element applies a rainbow pattern to parts of the surface that are almost facing away from the camera but not quite, which tends to be on outer edges. It picks where in the rainbow to use based on the angle perpendicular to the camera. So the sphere is the simplest example since it's just one continuous gradient of angles all the way around, so you get that full rainbow pattern going all the way around. Change the period to 0.5 and you will double the amount of rainbow repetitions along that angle range. But if you change the period to something like 0.6, you'll see that there's a hard discontinuity there, and that's because it isn't wrapping a full instance around. So what you want is an even division of an integer, so 0.5, 0.25, and so on. Use the phase parameter to shift the rainbow along that range of angles. So on the sphere, you can just see it's basically just rotating it around the edge there. You can also use the spread parameters to control the range in which that color gets applied. So you can either make it kind of a tight band around the outside or a more diffuse spread, filling even the entirety of the shape if you want to. Note that this type of shading totally ignores the light source, so if you move the position there, it's not going to change anything. That's because all it's using is the angle of the surface relative to where it's being viewed from. Next up is matCapContrib. Create a matCapContrib, and we're going to connect that in place of the iridescence. MatCap is a technique that basically fakes lighting and reflections. It's commonly used in sculpting tools like ZBrush. It's an inexpensive way to make shapes look like they have complex lighting and reflections without actually having to do the calculations of those in the renderer. It's based off of specially structured images that hold ranges of colors used for different angles of surfaces. So in order to get it to work, we'll need to provide it with one of those images. If you do a Google search for MatCap texture, there should be a bunch of different results. One of them that I like to use is this one on GitHub, usually the first result. So it has a whole bunch of different texture images that you can use along with thumbnails of all of them. So if you pick one of these pages and scroll down and pick one that you like, So you can see here next to this preview image is what the actual texture image looks like. So it arranges these colors to represent different angles, and those get used depending on where the surface is facing. So underneath those images, there's going to be a list of different resolutions. So you can pick whichever one you want and right-click that link and choose Copy Link Address. Then back in Touch Designer, in our matCapContrib, under matCap Texture File, paste that URL in. And it may take a second to load, and make sure that you're using that parameter, not the texture top one. The top parameter is useful if you already have your matCap texture image in a top and just want to reference it from that material. You can also use references to local files in the file parameter if you want to have that file saved in your own computer and don't have to have an internet connection. Similar to iridescenceContrib, this operator doesn't actually use the light, so if you move the light, you won't see any changes. Next up is skyLightContrib. Skylight is an inexpensive way to add some secondary pseudo-lighting to a scene. So we're going to connect our diffuse back to the modular in place of the matCap. Skylight is typically used alongside other shading elements to fill out the color. Create a skyLightContrib, and then we're going to connect that to the third input on the material. I'm going to drop the level down to 0.5 and then switch on Use Color. And try changing the color there. It totally ignores the light position and instead just applies whatever color you've chosen based on how much each part of the surface is facing a particular direction. So by default, it applies to surfaces that are facing upwards along the y-axis. You can change that using this direction parameter. So try adjusting that parameter, and you can see how it is changing which parts of the surface facing which direction are getting that color applied to them. Try moving the light source, and you'll see how it is affecting the diffuse shading, but it's not affecting where that skylight color is going. So this allows you to use a totally different light direction for your skylight. So it makes it kind of seem like there's a second light source without actually having the performance cost of having multiple light sources. As we saw with skyLightContrib, you can combine multiple shading elements into a single modular mat, and it will add up all the colors that each one contributes to the surface. Try connecting the iridescenceContrib either instead of the skylight or in addition to it. And that will give you that rainbow highlight around the edges along with the standard diffuse shading. If you want to combine these elements using something other than addition, you can use a separate combiner operator. Disconnect those shading elements from the material and create a composite fields operator. And we're going to connect our diffuse contrib and whichever other shading element you want to use. And then we can connect that to the first input on the modular mat. And by default, it's just using add, like the modular material would on its own, using its inputs, but you can change that to various different types of blending. And these are similar to the modes that are available in a composite top. You can also use the combine fields operator to combine your shading elements. It has a different set of options that are less focused on colors and more just on basic math operations. And that's it for this section. Stay tuned for the next video in the series. Check out my Patreon for access to scene files, exclusive tutorials, and more. Thanks for watching, and make sure to like and subscribe.